Hello, I'm John Furrier here at theCUBE for an AI industry panel, Scale Up and Scale Out Networking Revolution, setting the table for the next generation AI infrastructure investments and ultimately the utilities that are going to come from generative AI. We've got a great industry panel here, going to break down the new Tomahawk 6. We have Velaga, who's the SVP General Manager, Core Switching Group at Broadcom. Good to see you. Pete Del Vecchio, Data Center, Switching Product Line Manager at Broadcom. You're going to really bring into the chips to the market. And of course, we have the industry panel, Praveen Jain, SVP, GM of AI Clusters, Cloud Ready Data Center, Juniper Networks. Praveen, great to see you. And Kunjan Sobhani, he's the lead semiconductor analyst at Bloomberg Intelligence to bring the perspective. Gentlemen, thank you for coming on. I know Martin Hall, don't forget Arista, VP of General Manager, Cloud and AI Platforms at Arista. Martin, good to see you.
Hey, John.
Thanks for coming on. Guys, so we are hearing all about Tomahawk 6. Ram, set the table for us because this is a breakthrough at many levels and the industry impact to the ecosystem, to customers, and to what's going to be rolled out as the critical infrastructure for Gen AI is going to be part of this generation. Set the table.
Thank you, John. Look, we are in exciting times. The race towards AGI continues, and very often you read this news about potential gigawatt of data center being built here, a gigawatt of data center being built there, trying to build hundreds of thousands of GPU clusters, right? And then against this backdrop, obviously the question people ask is what role does networking play? And the role that networking plays is we say, hey, network is the computer because machine learning is a distributed computing system, and the network is what connects all of this together. So as we move towards these large, colossal supercomputers being built, either for training or smaller clusters being built for inference, we're excited about the role that networking plays, and specifically the role that Ethernet plays, in enabling these very, very large systems. And that's also the exciting part of the panel that we have here, which is we all believe in making this happen on a very open architecture, on a technology that is open and technology that is very widely adopted, in the world. So that's the exciting part. And, we'll talk a little bit more about Tomahawk 6 as we dive deeper into this.
Pete, you're the product line manager. Okay, talk about some of the core things that are in here that people should know about and the implications. What's the key breakthroughs from your perspective?
I think the key breakthroughs of Tomahawk 6 are just first, the high-level bandwidth, that 102 terabits per second. And this is the only switch chip at that bandwidth. It's twice the bandwidth of any other Ethernet silicon. We also have a variety of I/O options. So we have 200 gig SerDes, 100 gig SerDes. We will offer a co-packaged optics option. So we give our customers a variety of interconnects so they can build out different types of systems. And also with Tomahawk 6, it's not just about the bandwidth. It's not just about the speeds and feeds. It's also about the telemetry we have, the load balancing we have. So we can add a lot of efficiency to the networks and really advance the industry towards that goal of AGI by making the network, making that whole GPU cluster more efficient.
Arista and Juniper, you guys have the bread and butter networking down. You've seen the generations of innovation. What's the impact to you guys? Because you're threading it all together.
Yep. So, John, we jumped on the TH5 bandwagon early when it was released, and it just worked out in our favor. We were the first OEM vendor to release a 800 gig switch. And as per the 650 group, now we are 44% market share of 800 gig switch. So what we thought as a closed system earlier with NVIDIA and all the InfiniBand ecosystem, customers who deployed early with NVIDIA because no choices were available, or they were early in the game, they were not sure whether it will work or not. Now they are realizing that this is the right choice. This is the open choice, and that's where we are playing in. So it's working out great for us.
Martin, large-scale deployment, speed is the key theme here in Tomahawk 6. You guys are in the heart of it. What's the impact from your perspective?
Yeah, we like to think about it in kind of two ways. It's AI for networking, so more intelligence, more smarts, visibility, monitoring. That can be in the enterprise networks. But if you think about networking for AI, as Ram said, this is a networking problem at scale. And the scale just continues to increase. Traditionally, you talk to a customer, they talk about bandwidth doubling every 2 years. And now they talk bandwidth going up in 5x or 10x. And so you can't continue to build out these networks using the building blocks you have. Whether it's the Tridents, the Tomahawks, the Jerichos, these systems need to increase their performance so that you can scale out that network infrastructure to hit that next breakpoint for these AI clusters. And it's an interesting problem. You know, we're all very excited about the growth of AI in the industry, but on a day-to-day basis, we have to help our customers solve these problems. 2x, 5x, 10x scale. Where are the next breakpoints? You know, so some of the innovations that you get in this new Tomahawk 6 give us better traffic management, better visibility, better scale. And as Pete said, yeah, you have the 100 gig SerDes technologies that give you the integration to the existing generations. You have the 200 gig SerDes that allow us to push higher density, higher performance, higher scale as a building block, both for scale up and to scale out. So we're very excited about what we can do with the Tomahawk 6, integrating that to the rest of the Arista Etherlink portfolio, backward compatibility and consistency. That's what the customers are looking for.
Yeah, and it's interesting, you know, theCUBE's been around 15 years. We do a lot of the events. We hear all the jargon, all the discussions. Kunjan, I want to get to you because this year's the only year I can honestly say that I've been to all these events and I hear the word computer science, I hear SerDes, it's speeds and feeds. I mean, there's a thirst and hunger. The demand is really rocking. As an analyst, you're calling balls and strikes in this market. You're tracking everything. Is the game changing? Okay, one, is it the same game? And two, what's going on in the market? Because the demand curve is shifting, the cost curves are shifting, the impact on the economics are significant. I've never seen this kind of the nexus of product, performance, and economics at this level in my career. What's your take on this from an analyst perspective? Because the demand, the impact, what's your position?
I mean, look, the TH6 spec speaks for itself, and I'm sure Ram will talk about it more, but from an industry perspective, what I feel more excited about is the indirect benefits that the large hyperscale customers will have, namely the flexibility, freedom, and optionality untethered from a vendor lock-in. And the top three sort of demand that, again, indirect demand that I'm listening from the customers is this allows them to reduce a layer of switching and scale out. So that's directly dollars and cost improvement, which customers cares a lot right now. Secondly, it allows them to future-proof their path, whether, this debate around whether they want to stick to pluggables, whether they want to go LPO, whether they want to go CPO. They don't have to commit or marry to one today. They can still adopt the solution and decide when and if they are ready to choose one of these paths.
So staying on the Tomahawk before you get some of the impact on some of the trends, and I'll throw this out to the panel, whoever wants to jump on it first. It's a product impact, it's an Ethernet impact, it's an ecosystem impact, but the old days of packets moving from point A to point B is that's so complex. What's it about Tomahawk 6 that's going to change the game? Anyone want to jump at that first? I mean, because you have the product impact. It's not just moving packets around. It's not just networking. It's a lot of different things. What's the product value? Who wants to kind of help shape that discussion?
So let me start. There are misconceptions about InfiniBand, that's the network which can sustain the GPU to GPU, GPU to storage, all that kind of traffic. But with our previous deployments and active real deployments with the customers with TH5, we have already seen Ethernet is more than ready for anything you need. And TH6, it takes it to the next level. Just to give you a couple of examples where a lot of innovations in terms of the utilizing the network to the maximum capacity were already inside TH5. We call it load balancing technology, call it the DLB or GLB. Tomahawk 6, apart from the leads and feeds, power reduction and other things, increasing the scale of that GLB. Now suddenly if any link fails in the network, you're not underutilizing the network. Automatically network figures out itself how to route the traffic in such a fashion that now you're utilizing the fabric again to the 100% capacity. What it means to the customer, you are utilizing your expensive GPUs to the maximum capacity.
Okay, so now you're talking the language of the CFO. CapEx and OpEx kicks in. Now the other factor is power. Okay, power and speed. Impact to economics. What does that mean for the CFO? By buying less XPUs? Buying more? Are they more efficient?
I think it enables you to use more XPUs in your data center with a given power budget.
Yeah.
So one example we point out with Tomahawk 6 is that we see the clusters moving to, say, on the order of like 100,000 XPUs. With Tomahawk 6, normally they would be interconnected, the next generation XPUs, with 200 gig SerDes, 200 gigs per lane. So with Tomahawk 6, you can do that in 2 tiers of networking. For competing solutions, you need to have 3 tiers. Now, that might not sound like a big difference, but what that actually translates to is that you need to have 67% more optics. You need to have over 3 times the number of switches. So now the network power overall actually doubles. So what happens then is that, Tomahawk 6, you can now decrease the power that's going to your network, and in turn put that into your XPUs, the resources that are actually making the company money.
And there's another aspect to that. As the networking industry has moved quickly from 400 gig to 800 gig to 1.6 terabit coming soon, we've seen the power draw of the pluggable optics and the DSP start to dwarf the power draw of the network device itself. So one of the biggest questions we get from our customers is, how can we reduce that power draw? So yeah, you can reduce the number of network tiers, you can reduce the number of physical pluggable optics that are in the network, but how about we take a look at the fundamentals of what's inside that optic? So with the introduction of LPO at 800 gig and LPO still at 1.6 terabit, what you get is you get a 50% reduction in the power draw of the optical piece within that network architecture. A 50% power saving is something that you can't pass up, right? And so we're seeing customers now looking at that, and as Pete says, the network is the interconnect. What you get by saving power is you get more accelerators. And more accelerators gets you a better ROI, a better TCO, and so the CFOs are a lot happier. But we can also help solve that power problem from looking at a system level, not just necessarily the silicon level or the XPU level.
Yeah, the CFO loves that because they're the ones signing the checks. What's this cluster for? Well, I'll put that aside. Now let's get to the people who look at the performance. Now you're talking about reliability, disruption, downtime. That always comes up a lot. Power, I can see that. Now certainly as the scale gets better, that's when the cash register rings better for the CFO. But when you start talking about scale, the power and all these components, what's that impact for the workloads, the reliability, the operations? Think about the early adopters. You mentioned hyperscalers. Think about Meta or AWS, these big hyperscalers. They're running massive systems. So one little problem turns into an order of magnitude of complexity. Let's scope that. Most people, oh yeah, I got a server, it's got power, I can hear the power, the fan's on, okay, great. But that's not so like in the system. Scope the magnitude of the impact of the operations. Forget the power on the saving side. We just kind of check that, as a benefit there. But okay, what's the magnitude of impact?
So let me give you some math here, right? So let's hypothetically assume somebody is building a 100,000 XPU cluster. Just on the XPUs, you would end up probably spending somewhere between $2 and $3 billion dollars just on the capex for the XPUs. Now, when you're trying to connect these XPUs, the next thing you need the NICs, right? If you have 100,000 XPUs, you need 100,000 NICs. That might be somewhere between 100 to $200 million, depending on the kind of the NIC you pick. Then for 100,000 these XPUs, you have just over 200,000 optics. And if these are 400 gig or 800 gig optics, you're probably spending about $400 per optic or so and so forth. So you'll end up spending another $100+ million on the optics, $100 to $200 million on the optics. And for the switches themselves, you probably need about 2,000 to 3,000 switches. You're talking maybe less than $100 million, right? So you effectively have got $2 to $3 billion in clusters, XPUs. Then you've got another, about roughly $400 million of networking equipment. But then there is other, storage and other compute that you have to buy. And then obviously the rest of the infrastructure to run this stuff. So if you go back to a data point that we had from Meta a couple of years ago that said their XPU clusters were sitting idle anywhere from 20 to 57% of the time, waiting for the data to traverse the network. You have to ask yourself the question, which is, if $2 to $3 billion of XPUs are sitting idle, based on this network. If you can improve the performance of this network, even by reducing that idle time, let's say instead of 20 to 50% idle time, you reduce that idle time by 10%. Is that a big amount? That's a massive amount. So on a $2 to $3 billion XPU, you're probably spending, including the data center, the power, the TCO, everything that's coming into it, maybe over $6 billion on the data center. And if you are able to get a 10% more efficiency or productivity out of those XPUs, that's $600 million per year. And now multiply that size of the cluster by 10 times if somebody is trying to build a million cluster data center. And each one of these, for one of these large language models, so you have 5 or 6 or 8 different large language models people are trying to build. So these numbers add up into very, very large quantities very fast.
Kunjan, you mentioned the open ecosystem. I mean, he's describing the numbers. I'm thinking, which skyscraper's going up? I mean, this is design. This is a design decision. This isn't like a small little thing. The numbers are off the charts. So that's like not thinking about what electricity you're going to run in the building, or, I mean, this is a big decision. You can't get wrong on this thing at all.
And I want to, we addressed a lot of CapEx benefits, but also when we look at OpEx perspective, right? When you look at on what protocol does the front end network on the cloud runs today, right? Yeah. It's Ethernet. When we look at industry estimates on the scale-out AI backend network. This year, Ethernet probably, and you can argue about it, but has broke even or taken over in terms of the port count. Yeah. Probably next year will be the year where it will take it over from a revenue perspective to InfiniBand. But the other thing to remember, not just from a CapEx dollar deployment, and those benefits are obvious, when you think about these customers, what do they have their talent pool in terms of serviceability, in terms of the ecosystem software? They've had years of experience with Ethernet. It's very hard then to bring up either a new talent pool, serviceability cost to going to a new, completely different topology. So it's great for them in terms of OpEx. What also is great is it's an open ecosystem. So what does that allow? It allows multiple chip vendors to come in, multiple switch OEM vendors to come in and compete amongst themselves, gives more power to the customers in terms of supply chain resiliency. Again, a strategic cost imperative, and just price, it's always good for them when vendors fight among themselves to get the best price. So the customers would love that, obviously.
And open for innovation. Yeah. Like, I just want to give an example, if I can jump in, John, if you don't mind.
Yeah, absolutely.
So let's say all the load balancing or maximum utilization of the fabric or the network fabric, all the technologies which Broadcom has provided, if we are continuing to innovate on top of those. Again, the goal is to utilize network fabric to the maximum capacity. It's an expensive capacity, expensive network, but also making sure that GPUs are not idling at Ram was saying, right? So, like, we are innovating in load balancing area. Arista is doing the same thing. This is an example of an open ecosystem that everybody is just trying to innovate and bringing best to the market for our customers.
Yeah, like you start with performance. It's speed to feeds. It's scaling out the network. As you said, it's the multi-vendor interoperability. It's ease of use from the front end to the back end technology, that consistency. And then it's about reliability. So in the clusters at the scale that Ram's talking about, if an individual link dies, if an individual device dies, how do I identify it? How do I troubleshoot it? How do I remediate it? But if I've got an underlying performance problem that the cluster's not just working the way I expected it to, how do you dive into the traffic that's happening within the network? You need that advanced telemetry, you need the visibility, you need the monitoring end to end, from the NIC to the switch, across the multiple layers, all the way back to that NIC. And then pulling all of that back. That's where companies like Arista and Juniper come in, with our operating systems, our software innovations that give you that visibility on top of the underlying transport networks. So it's all of that that gives you that better together benefits.
It adds to their OpEx story, as you were saying.
Exactly. I mean, everyone's innovating, right? And we've been covering both your companies. We see the action happening. This is where I think there's a lot of old dogma confusing some of the conversation, how data centers are built, how should they operate the architecture. There's a lot of hype out there right now. So these are big decisions.
Okay.
Who wants to take a stab at
that? I do.
Okay, go ahead.
The reason I want to talk about something here, right, which is, as I said, machine learning is a distributed computing system. And when you think about this distributed computing system, the role that we believe networking and Ethernet is going to play is democratizing machine learning. It's a powerful word, but the reason I say that is the following, right? You don't want the whole world to depend on one company that makes an XPU that's controlling the pace at which the world is able to innovate and move forward. And people realize that an XPU on its own is not a differentiator, because the reality is we're all constrained by the reticle size of how big an XPU can be built, which is 800 millimeters square, and then you can put an interposer, have multiple of those, and you can make it slightly bigger and so on and so forth. But the reality is you're all physically constrained on how big a chip can be. Then you say, how do you build a large distributed computing system? The way you build a large distributed computing system is actually networking all of these different pieces together. So people have this thought that if they control the network, if they control the network, that they can actually control the entire ecosystem of who owns the XPU in the world. And if they do that, then they can continue to maintain, lack of a better word, a dominance in this space. So for us, the role that Ethernet's going to play is to essentially democratize the ability for others to build the XPUs, because then let everybody compete on the merits of their XPU, right? If you can build a better XPU than somebody else, may you win. But let it not be on the merits of a closed system by virtue of you owning the network, right? And we kind of see sometimes tendencies in the marketplace of somebody who owns the XPU says, well, my XPU will only work with my NIC, okay? And then, by the way, my NIC will detect whether or not I'm connected to a switch that is mine, even though this is supposed to be Ethernet. And if it is not connected to my switch, I'm going to disable some features on the NIC. So all of this is behavior or tendencies in the marketplace to try to continue to create a homogeneous environment, because really what they're trying to do is try to maintain a huge moat that prevents the democratization of the XPUs. So long story short, what I would tell you is networking is going to play an extremely important role in enabling the world to thrive going forward, where there is a multitude of XPU vendors, and they're all going to be connected over an open fabric. And the open fabric, the best open fabric, has proven out historically to be Ethernet. And by the way, these two guys will probably compete against each other till every day, and will fight for every deal. But the fact that they're here and they make their boxes work together, and Juniper does not turn off the networking switch based on whether it's connected to Arista or not, is what an open system is. And I think that is where the world needs to go for us all to move forward as a civilization.
Okay, Praveen and Martin. So you look at some of the AI workloads out there. The trends we're covering around clusters is two things happening. Tomahawk 6 speaks to bandwidth, more and more faster, scale up, scale out. We'll get that in the next section. But when you talk about bandwidth, the transit's got to be really, really fast, right? So, and if you look at data security, it's moving up the stack a bit. So there's a trend there where let's keep the networks flowing, right, going on. What's your guys' experience? Because now Tomahawk's going to bring more horsepower. The AI workloads will be running on them. What's your angle on this? Because, I mean, obviously Ethernet, the open side of it, but now we're getting into kind of a stack conversation. You don't want to make the network more complex, but you want more bandwidth. What's the path here? If you guys can share your thoughts on this.
Yeah, so first of all, network is complex.
Don't make it more.
So, and that's the reason some of these operational tools are extremely critical to let the data flow in the network. But at the same time, actually, before I say the next sentence, I would also just give you an example. A lot of the big clusters which are built out today with Ethernet, or for that matter, any technologies, link failure is one of the top concerns in these networks. So think about what example Ram was giving. So let's say we maximize the network and utilization is perfect. Nothing is coming in the way. These optics fail all the time. So let's say suddenly one optic fails. Now again, you have less optimal bandwidth, and maybe some workload is waiting for the other if you're not able to detect and correct in time. So I want to say that with the technologies like CPO, which Broadcom and Juniper are working together as well, we are hoping that we are targeting that links are more reliable than the current optics. So I just want to end with this: is network is complex, And with these kind of high capacity pipes which are going across for GPU communication, because ultimately you affect the workload, it's our job to make it simple by making sure all the operational tools are aligned and we are able to detect and react to these failures in a almost real time.
And if the standards aren't there, the tools get more complex. I mean, again, this is where it gets problematic.
Well said.
Martin, what's your take on this whole network's role and the tools and the data and workloads on top of
so from the fundamental link layer up, you reference the OSI stack.
Yeah.
Yeah, been there. 1.6 terabit Ethernet isn't more complex than 800 gig Ethernet. It's not more complex than 400 gig Ethernet. So as the speeds go up, what gets more complex is the system level design, integrating the SerDes technology, but that's our engineering team's challenge, if you will. That shouldn't present a challenge to the customer. The customer should be able to use the same familiar protocols, the same reliable software stacks, so that when they start to move from 400 to 800 to 1.6, it's not a new paradigm. It's just moving to the next higher speed. So to do that, you need to make sure that you have backward compatibility, the 100 gig SerDes to the 200 gig SerDes. We have that bridge to the future. Many customers are building out brand new AI clusters, but it won't be long before we're talking about building multiple clusters in a building and then interconnecting multiple generations, bridging between data centers in a campus, and then bridging those campuses on a global network. So the next challenge we see is that bandwidth explosion getting into the front end of the network, that bandwidth explosion getting into the wide area global backbone networks. So we're seeing this bandwidth shift. Yes, the back end is continuing to grow, and then the front end, and then the global WANs.
That's a very nuanced point. I'm glad you brought that up, because the SerDes speed, Pete, we talked about it a little bit on our deep dive, about the different speeds and the chips have different, they can work together. It's not, you don't have to have an upgrade. It's not like a big upgrade. The backwards compatibility and the engineering is already in there.
No forklifts.
No forklifts at all. It just plugs in. This is like a big feature. Like this is why the benefit of standards exists. Pete, we talked about that on our podcast.
Yeah. And I was reflecting on some of these comments too about, just standards, operational tools, wanting to have the same technology throughout the whole data center. I'm not sure, it sounds like you're gonna bring this up in the next section, but one thing I wanted to point out is that I think one of the unique things, one of the disruptors from Tomahawk 6 is that we're also seeing that it's gonna be used for scale-up networking. So right now, the narrative used to be that you want to have Ethernet for your front-end general data center network, you want to have InfiniBand for the back-end for the scale-out, and then some other proprietary link technology for the scale-up. But actually, we've seen that front-end, back-end, or scale-out, move towards Ethernet. I think the next step is to move towards Ethernet for scale-up. That provides you a much larger scale, so you can have 512 XPUs connected with one Tomahawk 6. And you can have your engineers who know the Ethernet to work on all the networking throughout the data center, and you have the same operational toolkit. So I think the fact that this is Ethernet-based, it's standards-based, it means that you can leverage the same technology. It's much better as far as operational efficiency, and you can take advantage of the full ecosystem of Ethernet for all parts of your network.
Well, since we're there, let's talk about it, because the scale-up is a big part of this. The scale-out's been around for a while in the discussion. Ethernet as a scale-up, scale-out is here. What does it mean? What does this mean for the industry?
Let me just step back and say why scale-up is interesting, right? Now, hypothetically, just think of this as an XPU instead of being a Tomahawk 6 with 100 gig SerDes on this. Typically on an XPU, what ends up happening is you'll end up having some HBMs on it. And today you may have 4 HBMs on it, each with multiple memory stacks, and soon it'll have 8 HBMs, or it probably already has 8 HBMs with multiple stacks. And you hear these HBM technologies like HBM3E, HBM4E. So in the HBM, the amount of bandwidth from the HBM to the XPU, they're all sitting on the same physical footprint here, per HPU could be about 10 terabits of bandwidth. Now, if you have 8 of those, you have 100 terabits of bandwidth of communication that's happening between the XPU doing the compute and the HBM holding the memory, right? Now, since it's a distributed computing system, what you want to be able to do is, if there is an imbalance between the amount of compute that's happening here and the available memory, you want to be able to access another XPU that is sitting next to it, which might also have another 100 terabits worth of HBM bandwidth attached to it, right? So the enabling that communication between this XPU and this XPU with that amount of bandwidth between these XPUs is what we refer to as scale-up, right? And now, when we're talking about the scale-up, it's not just about these two XPUs. Today in a rack, there may be 36 or 72 or 64 of these. But now you want to say, what customers are saying is, look, I don't want to be constrained by these numbers. Can I go to 100, 200, 500, right? So that's the opportunity for networking, which is very high bandwidth between any two XPUs, but up to 500, maybe in the future, even 1,000 of those connected together. And that's what we refer to as a scale-up, right?
Yeah, and so I think of scale-up kind of, from a pedestrian standpoint, I got the racks. Customers have a lot of racks. What are the challenges, guys, on this when the customers what's the new solution? They have pre-existing scale-up. Is this part of the new design? What are some of the challenges that people are going to see either deploying or migrating or rethinking it?
Yeah, so one of the challenges, right, you need to have both sides the same technology. So let's say, for example, if you have a GPU or XPU which doesn't talk the same Ethernet, then it's a problem, right? Like, for example, if you take today's GPU, if it talks NVLink on one side, then it's a problem how you connect. So ultimately, we need to come to the same consensus, which last several decades we have come to in realization that Ethernet wins at the end, right? Same thing here. The Ethernet will win and will prevail, but we need to make sure that all the open vendors are working together to settle on that technology. But once you start putting that into a form factor, we haven't talked about TH6, for example, now requires a liquid cooling. We talked about power, we talked about performance, but liquid cooling has become essential now. So now when you do the same thing inside the rack, even more complicated.
Yeah, liquid cooling is kind of, air cooling's good too, but if you can do it.
Yeah.
Martin, talk about the impact of this, because I brought the TCP/IP because I wanted to kind of thread it. Scale up is the preferred architecture when you look at massive distributed computing.
Yeah, it starts with densification, right? You mentioned about the racks.
Yeah.
Ram mentioned about how many accelerators you've got that are physically located together. You get higher and higher density of compute. The number of accelerators that are within a rack or a pair of racks isn't low single digits, it's not high double digits. You're now talking about hundreds of accelerators. So this becomes a networking problem. It's a networking problem. We solve it with networking technologies like Ethernet. It's almost a, why wouldn't you, right? And that's kind of the thought I keep having around this is like, Ethernet, well, why wouldn't you? We've already solved these problems of computing at scale. And then Praveen mentioned about liquid cooling and air cooling. I don't know that the network itself needs to be liquid cooled, but you're sitting in the same rack as accelerators and compute and storage that due to its density and its heat profile, we're talking hundreds of kilowatts in a rack. So the racks are going to be liquid cooled. And the choice then of the networking is, are you part of that rack ecosystem, or are you outside that rack ecosystem? Many customers today, most customers today have got completely air-cooled environments. You can't just walk in there with, hey, my new product's liquid cooled, are you ready for this? So we're going to have this hybrid phase for a period. You're going to have, even the hyperscale customers will have existing air-cooled environments you have to integrate to, and they'll have next generation, the liquid cooled. You need to integrate with those as well. So we are seeing that introduction of air cooling.
Well, it's not just the rack, it's the data center. I was talking to a customer and said that we have to retrofit our data center. I mean, you're talking about more CapEx that's not even needed if you don't. Again, this is a lot of efficiencies. Could you, the market size, it's a weird industry analyst, financial analyst kind of crossover because there's numbers associated with it, obviously what they ship and what people are buying, but also the category. I mean, if you said the network is the computer, the old model was I buy a server, I throw an OS on it. That's software. And the network's the operating system, because if that's true, the network is running everything. It is the OS. So that's almost a paradigm shift in terms of how to categorically size the market. What is the market? Is it networking or is it operating systems?
Yeah, and, as an analyst, when I hear the words TAM, CAGR, or market share, my eyes light up. So let me give you an example. When we look at most of the single connected XPU or GPUs right now are sort of in 8 configuration. And when you look at the cost of the BOM cost division, about only 60% of the total cost is for the XPU or the GPU. Almost about somewhere between, again, 20 to 30% is going for the networking, scale-up networking specifically, to connect these together, right? And why is it important is like, sure, you bought all of these very expensive Ferraris of a GPU, but if you don't have highways to drive them fast, they're useless, right?
Yep.
So right now, the entire market is run on one protocol. So there's a desperate need to, again, have open systems or have supply chain redundancy or have multiple protocols. But more than that, having a second, third, or another scale-up technology opens up the boundaries for these customers where currently it's just a black box. I mean, if you look at the current GPU leader, I would say one of the key master strokes in their latest generation of shipping is clustering higher and higher count of GPU comes from that NVLink ability, right? So that is the piece of the networking where you can extract the most leverage out of your most expensive GPU, which is highest dollar per reticle size that you're spending in your data center.
Yeah, and Ron was talking about the HBM and how the economics are working and the technical, but they're talking to each other too. So there's intelligence there. So it's now it's a systems game. All right, so how does the ecosystem evolve? There was more roads coming, or like the Ferraris drive, or more cars come on? So like, I mean, if the air cooling argument comes in, the racks will change, because why would I need a big rack if I can have an air-cooled system and I'll just change my configuration inside the data center? If the data center is the computer or the node or whatever you want to call it, that kind of changes the game. Am I thinking about this properly? Is this the way people are thinking, or is it like, I got a rack and I got this power, I got to put X number of machines on it? I mean, what's the thinking today, state of the art, for people who are building large-scale systems? Are they thinking this way, or what's the current stated mindset of?
Yeah, I would say, I think the most important thing that in the top of everybody's mind is, hey, look, at the pace at which these large systems have to be built, the supercomputers, or the amount of XPUs have to be deployed, it cannot be in the current ecosystem of an single vendor and where majority of the profit pool is going. Because like I said, you cannot have the volume, a cloud volume with enterprise margins, right? So I think the back of everybody's mind is, how do I actually have a multitude of XPUs be successful in the marketplace? That's the number one, okay? That has to happen. And when they think about how does that happen, then they say, okay, then we have to address networking, because networking has to be in place to allow for a multitude of these XPUs to be able to work together in these clusters. Once they think about that, then the next problem ends up becoming, okay, then how do you do scale out and scale up and all of this? So I would actually say these things like the scale out, scale up, people who are in networking, we can solve this problem, we're solving this problem, we'll make it interoperate with, multitude of, XPU vendors, that is going to get solved. And then obviously we are going to innovate where innovation is needed. So for example, rather than just, SerDes, either 100 gig SerDes or something like with this, a smaller one with 200 gig SerDes, we realized that there is a role to be played in, reducing the amount of power that copper or regular optics connections will end up taking. Copper because they're limited on the reach, and then the regular optics take a lot more power. So things like co-packaged optics and so on and so forth will come into play. So if you think about it, I think you can't lose sight of what is a long-term vision. The long-term vision is about, in a world where many millions of XPUs are needed, you need multitude of XPU vendors. And for multitude of XPU vendors to be available, you need a network that is capable of connecting anybody's XPUs together. And today, the technology that best plays it is Ethernet.
And the switches have to support the scale out
and the scale up. And the switches have to support the scale up and scale out. And those switches have to be interoperable across different vendors. And we are all going to be driving very hard to keep reducing the power, keep increasing the bandwidth, and more importantly, in a way that you're able to consistently do it every 24, 30 months and not be a bottleneck in the ability for the world to progress forward.
Yeah, and I have an opinion on this. I think the standards bodies is where the standards really can come in, whether it's de facto, certainly Ethernet standard, but as the de facto kicks in, you got the SU, you got the scale up Ethernet spec, you got Ultra Consortium, Ethernet Consortium. What's going on? What are the new specs involved in those areas? Can you guys talk about what's going on there and How could people get involved? What are they delivering? And what's the impact?
Just want to take it?
Yeah, I mean, the Ultra Ethernet Consortium, I think, is one of the consortiums that got the largest number of participating companies. So that's the silicon companies, it's the systems companies, and it's the end customers. So that participation is driving two things. It's driving that consistency, so we all get to the same destination, but it's also making sure we take in all the needs of that community to make sure that we get to the next evolution, right? It's not revolutionary, it's evolutionary. So a lot of the products that are out there today support the initial specs of the Ultra Ethernet Consortium, but there will be optional features, and those optional features can come into next generation silicon, that come into next generation products, and people can start to take advantage of them. So that's the benefit of having a multi-vendor, multi-customer consortium to make sure that we're all looking at the problem from the same point of view. We're getting the best and brightest in the industry to all work in it collectively. You don't have one voice dictating the direction of the industry. It's a collective.
And same thing goes for UA Link. Like we talked about NV Link, which is proprietary link. In the UA Link, we're trying to see how exactly that piece comes together inside the rack or inside the scale-up networking.
How about on the memory side? Anything going on?
The scale out, and then there is on scale up. You know, what's actually interesting is while scale up actually needs a lot more, bandwidth, order of magnitude higher bandwidth than scale out, scale up is actually a lot simpler than scale out. The reason why scale up is a lot simpler than scale out is because in the case of a scale out, usually when you have 100,000 plus GPUs, 10,000 to 100,000 plus GPUs, you need multiple tiers of networking. When you need multiple tiers of networking, there is a higher chance of link failures. There's a much higher chance of congestion, and basically load balancing issues and all of this that come to play. Whereas in the case of a scale up, these 10 or 100 plus XPUs, they're all directly connected through one switch hop, which means the whole load balancing becomes a lot simpler, congestion management becomes a lot simpler. And instead, what the network has to focus on is just making sure the connection is reliable. And number two, the other thing it has to kind of focus on is trying to get to as low latency as possible, right? Yeah. That is why what we have done is we've written a spec for how easy it is to do scale up on Ethernet, and we've actually submitted it to OCP saying, hey, look, this is how easily you can do it. This is what you do on the switching side. And by the way, this is what you do on the accelerator side, right? So we believe that, again, scale up will be on Ethernet, not some other, technology which is trying to create an, parallel version of, existing proprietary capabilities.
Yeah, shout out to OCP too. They've done a lot of great work here. And the SerDes example of 200 gig and 100 gig, that they can play well together. But I want to get you guys' thoughts on the packaging. You mentioned racks. I know there's rack standards. You got CPO. These are big deals that are coming out, the importance of those. Talk about that, guys, from an implementation standpoint, because Juniper and Arista, you guys are out deploying in real time. This is the ecosystem upside. And then the market opportunity, where does this factor into what's shipping? Who's getting what's boxes?
So maybe I can start. So we will have a TS6. We are actually actively working on TS6. We'll be releasing it ASAP. We'll have all the form factors, which include air-cooled version, the liquid-cooled version of TH6, as well as a CPO version of TH6. So that's what we are working on.
Martin?
I'm not going to talk about what we're doing until it's ready to talk.
Okay, good answer.
So I don't want to get into trouble with my boss.
Okay. We know.
But yeah, we're working on Tomahawk 6-based products to meet the customer needs. We're in deep conversations with those customers about making sure we align our product to their requirements.
Yeah, I know, Jason, you would definitely text me and call me. John, on the market side, this is going to really be where the rubber meets the road. Obviously, the numbers looking good. What's your take on the implementation of all this?
Yeah, Praveen or Martin might not like this answer, but every year when I go to the optical fiber conference, right, there's always a debate between how does the future of networking look like. Last 2 years, the debate has gone up significantly, whether you're talking about whether pluggables are the future, LPO, LRO, CPO, which one of these technology wins might kill the other, throwing copper in the mix. But what I'm really excited about is when we talk about this consortium, right? So if you just take a scale-up example, there's UAC trying to attack to scale up. There's UA Link There's folks trying to solve it through PCIe and CXL, right? So there's a lot more R&D dollars through the combined ecosystem now being attacked to this networking problem. A lot more engineering crown across these companies. So to me, it's like a lot of excitement is happening in this one piece throughout the ecosystem, which works out great. Now, I don't think the debate is solved, which technology wins, but more importantly, something like a TH6 doesn't, again, lock in the customers to marry and commit to one today. You know, they can still continue a part of their server through the incumbent technologies. They can play with LPO, CPO, and as and when they are ready to choose one, or one customer choosing one versus second customer choosing other, they can continue with that path. So really exciting time in that regard.
And the network is a great area because everyone has the same common interests. It's not a lot of competing missions. It's all, let's get it going, let's unify.
Yep.
And not all consortiums get 100% of their wish list done. And they settle in on some of the core. Scale up, scale out seems to be the sweet spot. Would you guys agree? That's like everyone's kind of striving to kind of get that piece of it?
Yeah, there's still room for innovation, right? So with everything you say around CPO, LPO, LROs, pluggables, there's still a lot of room for innovation. You forgot one, CPC as well, right? So the acronym soup is getting worse. But the innovation comes at the point of view of where the customer defines the requirements and the networking vendor starts to make sure we meet in the middle, right? So I think innovation isn't dead through having consortiums. It allows us to compete on a level playing field. It compete with our true value proposition rather than saying, I'm going to lock you in, and that's going to be my value proposition. So open doesn't throttle innovation. It actually encourages innovation.
You know, open always wins. I always say open always wins. I'm really philosophy on that one. No, I'm biased heavily, everyone knows that. But I think consortiums and standards really work well in big market shifts. It's almost like therapy in the industry. Everyone kind of, let's get behind the big things that move the needle. With that being said, you guys also not only compete, but also they're your partners and customers. You have to run your business. I know Juniper, we covered Mist, Arista, and the large scales. You guys have stuff you're working on. So, you know, the thing that got my attention on Tomahawk 6 was some of the telemetry, some of the load balancing, global load balancing. These also impact the system within the system, now different geographies. What's your guys' take on your side of the innovation? What's in it for you? Can you guys share what's on your side of the benefit statement here with Tomahawk 6?
Yeah, maybe I can start.
Yeah, start with you.
So, you know, there are two terms in the industry which we know, AI for networking and networking for AI. AI for networking, we know that it's about using AI to solve the operational problems in the network. If I may say, we now need AI for networking for AI, right? Because networking for AI itself is so complicated. How do you apply AI to simplify the operations? So luckily, as part of Juniper, we have our Mist technology, and Marvis is the core AI engine there. So what we are doing is taking that Marvis core AI engine, which is helping our wireless and wired and Wi-Fi customers in the campus and branch. We are applying the same technology to solve the operational challenges using the AI to our networking infrastructure or network for AI infrastructure. So that's the technology.
And any use cases that you guys see from your customers trying to connect the dots or the lily pads you have to jump to? What's the next step? What is some of the customer thinking around these large customers that you're seeing? What's the big trend?
Yeah,
and
so
looking
actually,
forward?
honestly, there are quite a bit of stuff which is going on right even now because we are innovating with the customer. So good part is everybody's new in this game, right? So we built our own lab where we have GPUs connected, ecosystem partners connected, underneath powered by the Juniper Ethernet. So we are learning day by day, but at the same time, when people are building large clusters, we are co-innovating with them. So I cannot share some of these details, but think about it at a high level, apart from bandwidth and how you set up these networks, the standards, the technology. Bigger challenge is how do you make sure that you operationalize this network and keep it running all the time. And I'm proud that with Marvis technology, we will be able to apply that technology, or we are applying that technology to the network for AI.
Yeah,
Martin, without getting in any trouble, what are you working on?
I was going to say that. So I'll talk about things we've talked about.
Okay, good.
So you're right. You have networking for AI and AI for networking. The networking for AI is transposing that experience we have on the front-end networks of the world's largest hyperscalers and folding it back onto the back-end networks. The same's true about the operational side of it, right? So the Arista EOS, open API, streaming telemetry, taking that real-time data and putting it into a single data lake so you can take real-time decisions. So some of the examples you get into that is, okay, I've got these large AI jobs running with long-lived flows that are relatively fat connections. So it's pre-positioning the flows, it's identifying when you're getting indications of congestion and rebalancing, reload balancing. So it's a software management API tier on top, interacting with the switch OSs that then interact with the counters and the packet interfaces on the individual switches themselves, taking that from the topmost network-wide view and then translating it down to this interface is starting to get busy, let's divert some traffic away. So making it usable, not just sitting there on, say, hey, theoretically we could do this. We'll put that into a practical implementation. Yeah. So we announced a feature, I want to say a couple of months ago, it was sometime in Q1, so I know it's in the past. Our CLB feature, cluster load balancing. We worked with a customer to identify the problems they were having with load balancing their AI workloads and came up with a new feature. We're looking at the RDMA Q pairs, so you're looking deeper and deeper inside these flows to get better and better traffic management, so you get better performance, which solves that ROI and TCO problem and the job completion times. So a practical example of a new feature that's implemented on the current generation of Tomahawks, and it will absolutely work on the next generation of Tomahawks.
Yeah, I mean, I can imagine, and feel free to share, both of you guys, on this, speed of cycle innovations on products. You mentioned two things there. New products are coming. How much of that velocity and timetable, if you had to go back, even 5, 10 years ago, a new product comes out every X cadence of the new products. How fast is the pace of play right now for you guys, given what's coming in? How does this new chip help or accelerate that?
So I'm never going to ask Ram to slow down on his pace of innovation, right? But I mean, none of us in our careers in this industry have seen this pace of innovation. The bandwidth we're getting on a per device basis, the bandwidth we're getting at a system level, the bandwidth at a network level, it's continuing to accelerate. So it's exciting, it's fun, and on some days it's a little bit scary.
Present a spot here. What defines the winners and losers in this game now? Is it wrong bet on the wave? Are they going to be on the wrong side of history? How do you look at the market? Okay, I can see the winners. How do you, as they say, don't play chess if you don't know what checkmate looks like. What does a winner look like in your mind?
I'll try to address it from the semi-chip perspective, not the hardware or OEM perspective. At this point, bringing back to the debate has gotten broadened. A lot more variables have been thrown in. So I think the winners will look like someone who can pivot very quickly, because the pace at the adoption at the customer level, it's so rapid. I mean, a few years ago when I talked to, let's say, two of a competing chip providers, and if one came 3 months or 6 months ahead of the other, it's like no big deal, because sure, you have a faster chip. The other player will have a faster chip in 3 to 6 months. The customers are going to take the adoption slow. The pace at which the customers are receptive to adopt the fastest, latest, whether it's compute or networking chip, is so fast that a 6-month delay could cost you the market. Yeah. So players who will be nimble, able to pivot and execute flawlessly at the high speed, will win. Of course, large players or incumbents have that ability, both in terms of the talent, experience, and dollar count. So it's the barrier to entry looks higher and higher now for new players, but we never say never.
Yeah, the old expression, I never forget this expression, move up the stack. I mean, it affects the hyperscalers too. I mean, not only the silicon layer, I mean, the hyperscalers are competing.
Oh yeah.
I mean, the delay there is, you could look at Amazon. I mean, they let Microsoft gain ground big time.
And I want to build on it. The scale is more important now than ever.
That's the reality, right? Which is, even a very, very large vendor can come and announce a product or a system today, and you will find a year or a year and a half later, they're still struggling to execute and actually get stuff out in volume. So obviously things like standards allow for interoperability, but at the end of it, whether it's a small company or a large company, is going to win out based on their ability to execute. And we always tell ourselves at Broadcom, which is our success is earned every generation, which is we can't rest on our laurels. We know that if we are going to be late on another chip subsequently, or we miss the ability to actually innovate, or set the trend in the marketplace, somebody else will win. That's both the benefit and the downside of an open system, right? You win on your own merits, but it's a big opportunity if you can execute.
Well, this is a great panel. Broadcom, appreciate the Tomahawk 6, great chip, great results, good Ethernet. I'd like to end with Martin and Praveen, if you don't mind, because I think you guys are the ones out there right now in the ecosystem participating. What's your vision? You guys are bringing this to the market. You got the customers. They're like moving as fast, and the demand is there. You have to deliver. What's your vision of the AI networking space? What are you going to do? What are some of your thoughts?
Yeah.
What are you optimizing for?
So we're optimizing for a lot of the things that are inherent to the Tomahawk 6, and that is scale out and scale up. But it's also allowing the customers to build larger and larger clusters without having to double the number of devices, quadruple the number of devices. So we keep thinking about the Tomahawk 6 as a 102.4 terabit, 100 terabit device. But behind that, you've got another tier of networking. So it's making sure that we've got a solution that isn't just a fixed system. When all you have is a hammer, everything looks like a nail. So you have a portfolio-based approach, so you can address the customer problem from the smallest to the medium to the very largest. So what we're looking forward to with the Tomahawk 6 is that next iteration in bandwidth and scale, but allows us to take our solutions to that next scale up. Expanding the Etherlink portfolio, I said it before, investment protection, consistency, don't lose features, don't drop technologies. Ram knows this very well, Pete knows this very well. We're still shipping products based on Tomahawk 1, and we're still talking about Tomahawk 6. So that investment protection across multiple generations, internally we talk about standing on the shoulders of the previous generation. Don't bet against the company that was successful before. We have significant market share in high-speed networking. We are investing heavily in this next generation of technology, and we're definitely going to have an exciting set of products at some point in the future.
Awesome. Praveen, your focus.
Yeah, as you know, right, in this market, there are a lot of early adopters, whether there are hyperscalers, cloud providers, big enterprises. There are early adopters where we are seeing huge successes. And those guys know what they need, and they are settling down on Ethernet. They realize that Ethernet is the right technology. So we are building the right product to address that market segment. But also what we are realizing is there are a lot of enterprises who are interested in deploying these clusters, whether for training or inference, and they may not have a know-how. So what we have done ourselves is that we built our AI lab inside Juniper, where we are getting our hands dirty, understanding what is happening, what's not happening, but also bringing these enterprise customers who are, like sometimes, for example, people are bringing their workload with some, let's say, dummy data to see how it looks. They compare their results with the InfiniBand and to say, now I get it. So in other words, what's happening is with our investment in this AI lab, with our hands-on approach, in fact, actually, Gartner recently published results, and it said we are number 2 in enterprise AI deployment, cluster deployment behind NVIDIA. So that's an acknowledgement of the work what we are doing. So in other words, we are looking at bigger customers who know and co-inventing with them because they're moving at a rapid speed, at the same time enabling enterprise customers to move to the next level.
Awesome. Could you get the last word? The semi market's hot, AI infrastructure, everyone knows is where everyone's waiting. It's like everyone's waiting on deck for the, come on, more speed. The market and AI infrastructure is super hot. What's the status? What's your vision? What do you see unfolding over the next second half of this year?
Yeah, I mean, when you look at the first 1.5, 2 years of this AI CapEx spend, if not all, most of the dollars went towards computing capabilities, right? Since we made this call last year, we published about it. Since over last year, we're seeing a lot more, comparatively lot more wallet share going towards networking, right? If you look at the fastest growing chip companies in terms of revenue growth, it's coming from the networking side. Yes, the compute is still growing, but when you look at the growth rate, who's taking more and more dollar share from the largest hyperscalers' wallet, it's coming in networking. But more importantly, now what what we see now changing is it's no longer just like networking chips standalone, but networking players now have an ability to upsell and cross-sell within a rack amongst a rack. Because there are these new use case sockets being invented or available which didn't exist before. It was simple. You got memory, you got compute and networking, but now given the innovation that the customers are trying to do, there are more TAM sockets available, and we see the networking players have a fair shot at grabbing them up. Simply put, it's increasing more revenue socket and silicon dollar content per AI server rack.
The stakes are high, there's big money involved, an upside, not only just for the people who are building the technology, but for the customers. It's an AI chip, this is an Ethernet moment. Gentlemen, thank you so much. People are building for AI scale. Thanks for your time, appreciate it. I'm John Furrier here in theCUBE. Thanks for watching.